So I'm showing how I've integrated the buttons to be in binary now. So if you come here, you'll see that when no button is pressed, that the 4 LEDs are lit up, which is like what we want the signal to be 1, 1, 1, 1 when no button's pressed. This is 0, so obviously, oh, I should note the LEDs are inverted from what you're seeing. So when the LED goes off, that represents the number bit. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Hey y'all, so I'm back now showing some progress. So I have implemented like the register flip-flop system so that when no button is pressed, it will hold the previous state. And also I've inverted it now, so instead of having one like LEDs light up for zeros, now they'll light up for ones, like to match intuition. So looking here, we have 1, 2, 3, 4 for our digits. So when 1 is pressed, you can see the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. And I've also implemented a way so it can distinguish between 0 and no buttons pressed. So when 0 is pressed, actually activates like one of the clears in the multiplexer, so it will in fact read all zeros out. Hey guys, it's Eliza coming to report in on my final project results. So, gosh, it works halfway. So let me show you what I mean. So right now, it's these 4 LEDs represent the target floor, so like the button you request, and then the LEDs right here represent the target floor. The current floor. So it's like this, what the sensors would be, and that's where my problem is. Integrating like simulating the elevator sensors in my circuit has been giving me a lot of problems. So first, let's just see what happens. So when both the elevator and the requested floor are at 0, we are in the idle state. So that's 0, 0. And let's see what happens. So when we request floor 1, so there the 1 is representing that, and what the heck? There we go. So here's the problem. So 0, 1, so that is the target floor, the state to go up. So this is like, if this had been attached to the elevator, it would be sending it up and then stopping. So somewhere in this circuit, the clock has like gotten into the input somewhere. I have looked at these wires so hard. I've like made diagrams on paper to try to keep track of what's going on. I'm worried that the problem is there's a faulty connection in my breadboard somewhere, and it's causing this signal to like somehow come into it. I just have no idea how this clock is affecting it like that. Then we press 0 again. It's still blinking? I just don't understand. So let's see what happens when we move the... So now our current floor is 8. And now both LEDs are blinking. I just don't know. Let's make our target floor 8, 0, 1, 2, 3, 4, 5, 6, 7, 8. So now we should be idling, because they match. But again, it's just blinking back and forth. And then when we press the ground floor, this is when we want to be entering the state 1, 1. Again, everything's just blinking. I'm not really sure. It works up to a point. So I have successfully encoded the floors to be represented in binary, have implemented the like logic so that when you aren't pressing a button, it holds the floor that you were last pressing. And then I have it all over here, but somewhere when I implemented the next state logic and all of the AND gates and OR gates, it all got overlapped somewhere. Okay, y'all, here's going to be a short clip explaining where the last thing that went right is. And it has to do with these LEDs here. So, here. So going from the top, we have, these are our inputs. So we have the not ground and ground. And then we have, here, we have ground, not ground, X0, not X0, where X0 is when target floor is less than the current floor. We have X1 and then not X1, so those are when they're either their target floor and current floor are equal or they're not equal. Then we have X2 and not X2. This is when target floor is greater than the current floor. Then M and not M. So this is when we are at 0. So this is when the current floor is at 0, this will be 1, and if they're not at 0, then this will be 1. So come over here. So, when the ground button is not pressed, you see the second LED, the really bright one, is lit up, but when you press it, the top LED lights up as expected. So going from top to bottom, we have ground and not ground, so button is pressed, ground is lit, and then we have X0 and not X0. So right now it's not X0, which makes sense because since the floors are equal, one isn't greater than the other. Right below X0, you can see the two LEDs that lit up. So is X1. So X1 should be lit up when the two floors are equal as expected. And then we have not X1, and then we have X2, which is not lit up because no floor is greater than the other. Then we have not X2, and then we have M1. So M1 is lit up because the current floor, current floor is at 0. Okay, so what happens when we request a floor that is above it? So now we see that because our target floor is greater than our current floor, X2 has lit up and not X2 is no longer lit up. X1 is no longer lit up because they're not equal anymore, and not X1 is lit up. Okay, so now we set it back down to 0, go back to the base case, and now we're going to have it so our target floor is less than our current floor, and we see now a new pattern. So now we see that X2 is lit up because the target floor is greater than the current floor. X1 is not lit up because they're not equal, and X0 is not lit up because current floor is not greater than target floor. So we can see here that the inputs to the next state logic are all working as expected. It's just somewhere here.